Hi everyone, thank you all for joining. My name is Gonen, and I'll be talking about how we managed to adopt GraphQL in Wix, but in a really special way, different, I would say, not normal at all. And basically, I'll introduce the story, how we managed to adopt it, and eventually how the architecture looks like and how we managed to solve the problem. So a little bit about me. My name is Gonen, or Gonen in American. That's usually how Americans call me. I've been 7 years at Wix. Today I lead a group called the API Infra Group, which I'll describe later. And to be honest, I've been knowing GraphQL for around 8 years or so. And my GraphQL story starts with a friend, Dotan, which I guess many of you know. Dotan introduced me GraphQL in 2015, where he just approached me and said, there is this new thing called GraphQL. Okay, that's how the story starts. And one thing that really got me into GraphQL is the fact that you can actually solve relations pretty easily, meaning that you can dispatch a single request, aggregates data from multiple data sources, and then return them back as a single response. So that was one thing that really got me into GraphQL. And as a GraphQL enthusiast, I really wanted to bring GraphQL to Wix. Now, we'll soon explain what's Wix and so. But, as a developer that just joined an organization, it's not that easy to bring in a new technology. You really need to understand what complexities and architecture and problems that you have in the organization before actually putting a new technology in the organization. So this is our talk. And two things that I want you to to understand from this talk is, before we dive into the technical details, is what's even Wix? Why do we want to expose Wix APIs? And more than that, why do we want to do it automatically? I mean, GraphQL is already complex. Why do we need to generate a GraphQL server automatically over and over again? So let's talk about Wix. A bit of context. How many of you know Wix, if any? Okay, that's pretty respectful. So Wix is widely known as a website builder. Basically, I think it's considered one of the best drag and drop website builders out there. We have tons of users, tons of sites, and so on. And Wix started as a regular website builder. I think that pretty quick, Wix figured out that just being a website builder is not good enough, and we need to provide a layer on top of our website building. And this layer should be what we call in Wix business solution. And by business solution, we mean that we actually create a solution for a certain business and allow users to manage their business within their platform. So specifically speaking, if we take the Wix restaurants, which is the use case that will guide us through the whole talk, when as a user you install the Wix restaurant app on your site, it allows you to manage your menu in the back office. And when you are done with managing your menu, you actually can publish it, and then you see your menu in the live site. Okay. So such as restaurants, we have many other business solutions out there. We have stores, we have bookings, we have groups. I mean, we have tons of business solutions. And our business solutions were great, but, unfortunately, we cannot solve it all. I mean, we're a big company, but not that big enough to solve all of the problems out there around the world. So one thing that we figured out is that instead of I wouldn't say instead, but aside providing the classic business solution for, I would say, non-top-notch developers, can we actually provide building blocks of these apps and provide developers with these building blocks so they will be able to build what they want on top of these building blocks? So if we take Wix restaurants as an example, when you imagine restaurants in your imagination, it basically consists of multiple parts, okay? You have the menu, you have menu sections, you have menu items, you have orders that are taken within your restaurants, you have tables that you need to manage, and each part is a standalone part that we can actually provide for developers. So aside providing the Wix Restaurants app, we could actually provide APIs that were built to serve the Wix Restaurants app, but also provide developers with these APIs so they can integrate with other platforms and build things that we in Wix can't really reach to and solve. And restaurants is just an example. We have tons of APIs out there. Just to name it, we have, I think, around more than 1,000 API that are currently being used in production. We have tons of building blocks and entities that are being measured within our APIs. And as you can understand, a use case is a bit unique. I mean, we have tons of APIs out there. And so why we do it? Why do we really want to provide developers with APIs? So we have two main reasons in Wix. The first thing is that we have the Wix app market. We actually want developers to build apps on top of our APIs, put them in the app market, and monetize. I mean, when a user install your app, you can monetize from this app, and you can, if you made an it and built a great app, then most probably it will be installed multiple times, and then you can gain money. So that's the first part. And the second part is called Wix Headless. Wix Headless is a new solution that we've launched, I think, around 4 months ago. And as you understand, I guess that you are all developers. And as developers, you don't really want to build a website using a drag-and-drop editor. Most probably, you want to use your React technology, Vue, Svelte, or whatever you want to build your site. But, once we separate the editor and the APIs, and we actually provide the APIs for developers, then developers can build sites the way they want to build and still use our APIs behind the scenes, okay? So let's follow on with Wix restaurants. So this is I think, the selling point of GraphQL. Let's say that we have a view. This view consists of 3 data sources. This view describes a menu. A menu has a name. Specifically speaking, we have the dinner menu. Each menu has 3 sections. Specifically speaking, the drinks, main courses, and desserts. And each section has its own menu items. Okay? Now, the way it was implemented behind the scenes, probably for good reasons, is that each of the parts that I spoke of is a different API. So in order to build the simple menu, you'll find yourself dispatching 3 requests one after another, right? You'll first fetch the menu, and once you get the menu back, you'll fetch the sections based on the section IDs that the original menu returned, and same applies for the menu items. So eventually, you'll dispatch 3 sequential requests in order to render your page. And we all know it's problematic. It's a waterfall request problem. When you dispatch multiple requests one after another, it takes a lot of time for your page to load. So we thought that we were smart in Wix around 6 or 7 years ago. And our go-to solution for Wix developers was to tell them to build a view server, meaning that if you need to aggregate data, then build a view server that would aggregate the data. And eventually, you'll find yourself dispatching a single request to the view server. The view server will dispatch 3 requests, but they will be within the data center. They won't be over the whole network. And then you'll get a single response in return. But when we talk about external developers, they do not really have a way to build a view server and host it within the Wix network, because the Wix network is closed. So that's where we figured out that no matter what we do, we won't be able to solve the problem for external developers. And fortunately, there is GraphQL. Okay, I guess that it's not new for you, but when I try to describe GraphQL to people, one sentence that I use over and over again is to stop thinking about your APIs as a bunch of flat endpoints, but rather as a big graph that you offer for developers to consume. And every developer can ask for a subgraph of the whole graph in a single request and get in response a single response. And now enough theory, let's be practical about GraphQL and Wix. So first, I'd like to start with some context about our API evolution. The first phase of the business solutions, one thing that we've been doing is we've been implementing API without really considering that much about the usage of the API. Meaning, there was a product manager that came with a request. There was a front-end developer that was building the widget. There was a back-end developer that was building an API that served the widget. And basically, that's it. You only cared about the widget going on to production, which, back in the days, it was good enough. But as we grow, it didn't really scale. And then after, I would say, before 5 years ago, we started to treat our APIs different. So instead of creating tailor-made APIs for specific use cases, we started to build APIs first, meaning that we designed the APIs, considering the use cases that we have in Wix, but we also think about other use cases that other developers can use. And technically, the way we did it is by using Google protobuf. I'm not sure how many of you know it, but if I read the dictionary definition of Google protobuf, protocol buffers are language-neutral, platform-neutral, extensible mechanisms for serializing structured data, meaning that you define your API in a protofile, and then you can generate from this protofile classes and types to use in any language that you'd like, okay? Now, one opportunity that rose once we started to use protobuf is, there is the direct benefit of protobuf, but one thing that we had is suddenly we had a technical source of truth for APIs that we can actually parse and start to understand how APIs works. And for instance, if we take I just put an example of how describe a method in protobuf look. So here you can see how we describe a method called create menu, which gets as an input to the create menu request, which is another message that is referenced somewhere, and returns the create menu response. And we also added the HTTP path for this method, okay? Now, this was the second part. So suddenly, we're in a stage where we have a schema for all of our APIs, unlike, scenarios where we have the design doc of the API, which is some Google doc, and then we have the implementation. They are not really interconnected. Once we started to use protobuf, our runtime was dependent on the protofile, and you couldn't really implement another API than the one described within the protofile. And the last part was, we had a schema. It was good, but not good enough. The last part that was missing is, we still had the flat list of APIs. And we wanted a way to actually group APIs to a single meaning. Okay, so for instance, instead of, having some create menu API and get menu and so, we started to think about the menu as an entity, which has its own attributes and its own actions. So specifically speaking, I know that it's not looking that good, but you can actually see an example of how we describe using Proto the menu entity. And one of the most important part of moving to such a paradigm is that we actually were able to declare connections between entities, okay? So in the red, you can actually see that I have the section IDs field, which actually reference to a different entity called the Wix restaurants section, okay? And suddenly, from a stage where we had APIs that were pretty flat, we were started to building a graph without actually thinking about the graph, okay? So we had the menu as the first entity. The menu as an entity had its own attributes and its own actions. The next part was to actually create the links. I mean, we have, in the scenario that I spoke about previously, we had three entities, the menu, the section, and the items. And each one was referencing to another one. And suddenly, we built a graph of entities within Wix without really thinking about it. And when you look at this graph, you suddenly, it starts to look like something familiar, right? I mean, it starts to look like GraphQL. So the question was, can we convert this graph that we already had in the organization to GraphQL? And the answer is yes, okay? But this yes has some implications behind the scenes. It's still not that simple. But let's talk about the yes still. Let's say that we have the menu, the section, and the items. Each has its own attributes and actions. Now, if you merge them together, you can actually create a schema for the menu, which has a name, which is the name of the menu entity. And the menu has a nested field called sections, where section is actually the entity that menu refers to. Section has ID and name, as you can see here. And sections also has another reference to items. So we have another nested field called items, which are the menu items, holding the name, the price, and the image. So technically, we were able to transform what we had in Wix to a GraphQL schema. Sorry. So given the fact that we can do it, let's talk about how to do it. So how would a classic GraphQL adoption look like in Wix? So let's say, Wix is the R&D department consists of around hundreds of backend developers. Adopting new technology is not necessarily that easy. I mean, we already have a well-established ecosystem. Developers know how to work with the APIs. Specifically speaking, today in Wix, we have the protofiles, which are the source of truth for the APIs. And each API has two API layers. The first one is the REST, which you already know. The second one is gRPC, which is mainly used within data center and cross services. And as we have a well-established ecosystem, we actually, developers are already familiar with the stack, they are experienced, we have standards, and you have a single source of the API, meaning that every time you have a new field, it's already reflected automatically to the REST and RPC. Now, if we suddenly decide to adopt GraphQL as a third technology, then developers will need to get to know with a new technology. Okay, we need to set new standards, and setting standards across hundreds of developers is not necessarily that easy. And the first thing is that each API change should be reflected manually into the GraphQL schema. Okay, so the idea is there technically it's possible, but operational-wise it's not necessarily cost-effective. So we still wanted to adopt GraphQL, but operational-wise we weren't really able to do it. So the question is, the answer is yes, but are we able to adopt GraphQL, benefit from the goodies, but still overcome the adoption problem? And the answer is yes. Okay, so I'll speak a bit about my group so you'll get a bit of context. Since we have tons of APIs in Wix and we have tons of backend developers, we have the scale problem, and not necessarily the scale of a service that needs to serve many requests, but rather, when you have tons of API, then documenting them and creating SDKs from them is extremely expensive, okay? Because, documenting an API is an expertise, and creating SDKs in various languages is also an expertise, and it's not really that easy to do it manually. So what my group did is try to solve those things automatically. So for instance, if I'm talking about documentation, if you go to the Wix API documentation, you actually see documentations that were automatically generated based on the protofiles, okay? Same applies for the SDKs. When using Headless, we actually provided developers with SDKs in both Node.js and JavaScript, and all of those SDKs were generated automatically. When you check the source code, you will not necessarily understand much, but technically, these SDKs were generated by a machine. And now let's see how we can actually adopt the GraphQL without the burden of adopting GraphQL. So I'll start with a demo, and afterwards we'll dive into the architecture. So you can see the GraphQL playground of our GraphQL schema. And first I'll try to build a query that we spoke of previously. So you can see the query where I fetch all of the restaurants menus. And for each menu, I ask for the item. And for each menu, I also have the sections, the name of the sections, and the menu item name. And once I dispatch the request, I get in response the menus, a single menu with 3 sections, the dinner menu, the mains, and the drinks, and each has its own items. Now, what we did technically is exposing the APIs of Wix restaurants using GraphQL, but without really involving any Wix restaurant backend developer in there. And Wix restaurant is just an example. We actually have tons of APIs that were already generated automatically based on the ecosystem that we built behind the scenes. And it's still not the final word. We still have many business solutions that we want to put into this solution before making it publicly. But as you can understand, it works, okay? Now, putting the demo aside, let's talk about the technical part and how we did make it happen. So we spoke about the entity relations. We spoke about the fact that each entity has its own attributes that define it, and it has its own actions. And one thing that I didn't mention, I'm mentioning now, is that every entity has a standard way to query it, and it's extremely important for this implementation. I mean, no matter if you query menu, products, collection, or any other Wix entity out there, there is a standard way to query it. There is a query method that gets it's a request. You can pass an array of IDs, for instance, and get in response an array of entities. And when we have these two parts combined, meaning we have a schema for all of the entities. We have the relations for all of the entities, and we have a standard way to query the entities. That's where we can automatically generate the GraphQL schema. So I draw some diagrams just to get the look and feel. So basically, developers write their protofiles in GitHub repos. Each API can be in whichever GitHub repo it wants. But during the master build, we actually have a service that gathers all of the APIs, all of the protofiles, parse them, and saves them within the service. The service is called in Wix the schema API. And basically, it's an API for our APIs. You don't need anything beside this API to call an API in Wix, in whichever protocol that you would like. We hold all of the schemas of all of the methods, all of the entities, all of the relations. I mean, everything is there, okay? So suddenly, we're in a state where we have a service which holds all of the metadata of our APIs. And then we built a compiler. And what this compiler did is every time there is a change within an entity, it generates for this entity both schema and resolver. Generating a schema is pretty easy because we already have the fields there. But in terms of resolver, basically a resolver of the entity is just the standard way to query it, which is the query method. And what happens behind the scenes is that for each entity, we generate both schemas and resolvers. And we generate a big NPM package that holds all of the schemas and the resolvers that we have in Wix. So just to get you the look and feel, this is a GitHub repo that holds all of the entities that we have in Wix. Everything is automatically generated, and this one is not necessarily the good example, but if we check the menu item, you can actually see that the schema of the menu item was automatically generated, and same applies for the resolver as well. We had some metadata for the resolver in order to dispatch a request, but basically that's it. All of the entities that you see here are entities that were automatically generated using our GraphQL compiler. And once we have all of this data, I think that the last part is pretty easy, right? Because you have an NPM package with all the schemas and the resolvers. And then what we built a really simple GraphQL server based on Yoga server by the Guild, where the server loads the schemas and the resolver and then hosts them. And basically that's it. Now, how a request is actually being dispatched, it's also pretty easy. Once a query reaches to our GraphQL server, the GraphQL server gets the request. It parses the fields, of course, because that's what the GraphQL engine gives us out of the box. And then using gRPC, we actually call the services behind the scenes. So if we get a menu request, what happens is that the GraphQL server uses the auto-generated resolver, calls the menu service, get the menus back, and then dispatching the second request for fetching the section service, fetching the section data from the section service, and then eventually fetching the menu items. So now we still have 3 requests, but all of these requests are happening within Wix data center. They are considered as much more efficient calls, and they are dispatched using gRPC. So that's it. In the next few weeks, we intend to make this schema public for developers to use. And to be honest, we actually meant to launch it today, but we didn't manage to do it, mainly because we wanted to be full with many other capabilities that are not here today, such as products, catalog, and some business solutions that we consider as highly anticipated. So once this is done, which will happen in the next few weeks, we'll launch it. We'll launch the GraphQL solution, which is a single GraphQL schema for all of the Wix APIs. So thank you all for listening. That was me. Feel free to ask any questions, or later we can definitely discuss.
If you have questions, please grab the microphone from the table.
Thank you. Okay, let's have a cup of tea then. Yeah. If you can be louder, because I can't.
Can you please grab the microphone so that they can hear?
Thank you.
Hey, thanks for the presentation. So my question was regarding the GraphQL compile when you auto-generate the resolvers. So how do you actually auto-generate different merge configurations, for example, menu sections or items that you have shown? Like they all work independently?
Each resolver works independently, and
Yeah.
what we added, I'll go back to this. One moment, I have a slide for it. But in this slide, we actually generated a virtual field called sections. Okay, and solving the relations is by adding a virtual field, adding some custom resolver which get the context of the for in this specific scenario the menu. And as far as I remember, we actually get, no, I'm sorry. Each menu has its own section IDs, and the virtual field is actually, the way it's dispatched is it takes the section IDs, dispatch the query method that was generated for this section entity, and then it gets the sections in return. Does it answer your question?
Yeah, part of it. But say if there is any other primary foreign key relationship, which is
No, we actually built it all in-house. Maybe we can someday take it outside, but a big part of the solution relies on internal solutions that are not necessarily part of the spec or so. But if one day, then we can definitely take it out.
okay. And one more question
Sure.
is regarding the nested queries again. Like, how do you guys solve the pagination issues or anything? Like,
Okay, that's a great question. So currently, what happens that it depends on the scenario. Let me find it. No, I don't remember where the slide is. Okay, but basically it depends on the scenario. Our pagination in Wix is not as standard as Relay yet. We do intend to solve it, but currently in Wix we have our own implemented pagination. We can discuss whether it's good or bad. But pagination basically, the way we solved it is, let me recall myself. So the way that you can fetch page and you go next prev, and so it really depends on in which vertex you started. Meaning, if you started from a single vertex, and the vertex itself, if we take the menu as the main vertex, and then you add the sections, then when we fetch the section from our APIs, we actually got the pagination metadata to go through the sections. Okay, so this thing is resolved. But when you fetch, I would say, multiple vertices at the root, this is when things start to get problematic. Now what we do is that we actually, for each one, dispatch a request in order to save the pagination metadata. Because on the opposite, if you'll use a data loader to fetch all of the kids, we'll lose the pagination because the pagination need to be in the context of each of the fathers that reach the data. So I'm not necessarily sure that we solved it, the state-of-the-art solution, I would say. But we solved it in a way that we currently allow pagination. But it was a great question.
okay, cool, thanks.
Sure.
Hello, I think you just mentioned you use data loader. So do you also co-gen that?
Once again, can you repeat?
Do you also co-gen the data loader in your
So
compiler?
we do use data loader when possible because, as I mentioned, sometimes it's not possible because we use the cursor metadata when we want to paginate among the children of the graph. And we do use cogen, but in the client that we generate to communicate with our APIs. We also have a client that is not public yet, but once we'll be public, we'll use the GraphQL cogen by the guilds to generate the types for the queries that you run as a consumer. So yes, but within this solution of the GraphQL compiler, we didn't make any use of the GraphQL cogen.
Any learning about how to maintain like special case or corner case?
How to maintain what?
Like special case and corner case when you cogen or like in the compiler?
To be honest, I don't have much of nothing special. I think that, the only important part, I mean, our solution is pretty simple. I mean, we didn't do much. The whole ecosystem that allowed it, meaning that you declare your APIs in a technical way that can be inferred later, that you declare the relation, that you model your APIs as entities, that was the main thing that solved the problem. Our solution, to be honest, was it took some time, but it was pretty simple. So nothing really special that I can think of, to be honest. Sure.
Sorry, one more question.
Sure.
So you have mentioned you guys are using data loader, right? The data loader we all know is used to solve the N+1 problem to try to batch the request. What if let's say if you are using some upstream API that doesn't support batching itself, then data loader won't be of much help, right? Did you ever encounter such issue?
Fortunately, all of our APIs support batch out of the box. I mean, this was one of the assumptions that we have a standard way to query, meaning that we have a standard way to batch the request. So technically it's there. If it's not there, to be honest, I'm not sure what I would do.
Okay. Thank you.
Sure.
Could you give me an example? For example, if you have like a legacy service, right, or like an older service that doesn't adopt gRPC.
Yeah. So actually, it's a great question because this is the main reason that we delay the release. It's because we have legacy services. And the way that we intend to solve it is to actually dispatch HTTP requests within the data center. I mean, instead of using gRPC, we'll actually call an HTTP request to the specific pod, for instance. And then, the request will still be short because it's within the data center. We'll not use gRPC, but I guess that it will be also as efficient.
Thank you.
Sure, welcome. So we're out of time. If you have any questions, feel free to reach me out. And thank you all for listening.